Here's an explanation of the FCFS scheduling using the push and pop operations. So first is creating the queue class. A class named queue is created. Self.queue is equals to empty bracket creates an empty array or list to store the processes, and this list acts as the queue. The push operation, which is def push self comma item, is used to insert a process into the queue. Item represents a process like PI, which is the ID, and 5, which is the respective burst time of the process ID. Self.queue plus equals to item adds the process to the rear of the queue. For example, initially the array was empty, and after push P1, 5, the P1 process ID gets into the array. So after push P2, 3, P1, P2 gets added to the array. The pop operation removes the first process from the queue, and self.queue equals to 0 removes the first process. Del self.queue 0 removes it. The remove process is written. For example, before the array had P1, P2, and P3. After the pop operation is given, the P1 ID gets popped out and only P2 and P3 remains inside the array. This follows the FIFO, which is first in, first out principle, as the first process ID, that is PI, is removed instead of P3, which is the last process ID pushed. Fourth is checking if the queue is empty. Def is empty self, return length, self.queue is equals 0, checks whether the queue is empty. Returns true if no processes are left, and returns false otherwise. The creating the queue object, queue equals to queue function, creates an object named queue. This object will perform the queue operations, creating the processes which gets into P1 and the burst time respectively, P2 and the burst time respectively, P3 and the burst time respectively, and for P4. Stores the processes. Each process contains process ID, burst time. For example, P1 has the burst time 5, P2 has the burst time 3, P3 has the burst time 8, and P4 has the burst time 6. The seventh is inserting processes into the queue. For process and processes, queue.push process inserts every process into the queue using push. The queue becomes front P1, P2, P3, P4 rear. Initializing the waiting time equals to 0 and the total waiting time is also equals to 0. The waiting time stores the waiting time of the current process and the total waiting time stores the sum of all the waiting times. Printing the heading, which prints the FCFS CPU scheduling and the title and column headings of the output table. Processing the queue while not queue is empty. The loop runs until all processes are executed. If it stops when the queue becomes empty. Removing the first process removes the first process from the queue, stores PID equals, which is corresponding to the process ID, and burst, which corresponds to burst time. PID is equals to P1, burst time equals to P5, for example, and calculating the turnaround time, which is turnaround is equals to waiting time plus burst time, which calculates turnaround time. And so as a result, the waiting time, burst time, and turnaround time is calculated. And this prints the process details in tabular form. If we have an updation, it will update the total time as we change the waiting time. So it adds the current process's waiting time to the total time and updates the waiting time for the next process. The next process waits until the current process finishes. And this displays the average waiting time rounded to 2 decimals. So the program flow is, it starts, creates queue, push all the processes into queue, pops the first process, calculate waiting time, calculate turnaround time, display process details, repeat until queue is empty, calculate average waiting time, display average waiting time, and then stops.